Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're starting chapter 8. This is 8.1. The name of this lesson is Find Angle Measures in Polygons. Our essential question is, how can I find a relationship between number of sides of a polygon and total angle measures? So this chapter is mostly going to be about quadrilaterals, like squares, rectangles, rhombuses, that kind of stuff. But polygons is kind of this is kind of an introduction to angle measures of polygons. So that's what we're going to be talking about today. There should be a kind of a flow chart for quadrilaterals that will be helpful this chapter. There's different properties of quadrilaterals that we need to know. And so let's go ahead and get into this here. No warm-up for today, so we're going to get right into it. A diagonal is a segment that joins two non-adjacent to what? Non-adjacent. What does adjacent mean? Adjacent means side by side, so non-adjacent would be not side by side. The actual other word that they used in the book was non-consecutive, or in a row, is another way to say that. Okay, but I think non-adjacent is a little bit better. All right, so there's a kind of a formula we need to know here, okay, for the interior angles of a polygon, okay? And the sum, which means if we add them all together, add up all the interior angles of a convex n-gon, however many sides it has, the formula is going to be n minus 2 times 180, okay? N minus 2 times 180, and that's going to give you how much they add up to here. Okay, now where does this come from? Well, let's just draw a triangle over here, right? This is a basic type of polygon. So where it kind of comes from is basically like we're kind of splitting up polygons into like triangles, and every triangle adds up to how many degrees, right? Triangle adds up to 180 degrees, right? So for example, if we do a triangle, we do the n minus 2, which is, n is the number of sides, by the way. N equals number of sides. All right, number of sides of a polygon. So how many sides does a triangle have? Well, it has 3, so if we do 3 minus 2 times 180, okay? And what's 3 minus 2? Well, that's 1, and 1 times 180 equals 180, right? So there's basically 180 degrees inside of a triangle, and you can see if we split up this polygon and go from 1 to 3, and 1 to 4, and 1 to 5, right? And if we do this looks like it's a, let's see here, 1, 2, 3, 4, 5. It's a hexagon, right? Let's try this. There's 3 triangles in here. So if we have 6 sides, minus 2 times 180, minus 1, or times 180, so we got 4 times 180. Well, how many triangles do we have in here? We have 1, 2, 3, 4. You can see we have 4 triangles inside there, so it's basically going to be, 4 times 180, which is going to be, I don't know what that is, but yeah, it's basically how it works, okay? All right, and then a kind of a corollary means like for quadrilaterals, if we have a rectangle here, how many triangles can we fit inside of a quadrilateral, or inside of a rectangle? 1, 2. So there's going to be 2 times, it's going to be 4 minus 2 times 180, which equals 2 times 180, which equals 360. So a quadrilateral, always the interior angles add up to 360, because there's two triangles that make up a rectangle, or a quadrilateral. Okay? All right, so let's go ahead and do an example together here. Example 1, find the sum of the angles measures in a polygon. Find the sum of the measures of the interior angles of a convex hexagon. Well, how many sides does a hexagon have? Well, n, the number of sides is going to equal, a hexagon has 6 sides. Okay, so the formula, let's write out the formula again, n minus 2, in parentheses, times 180. So we're going to plug in 6. So we got 6 minus 2 times 180. And then 6 minus 2 is 4, and 4 times 180 is going to be 720 degrees. And that's it. That's all you got to do. All right? So that's how we use the formula. So basically, if you calculate the number of sides, like I said, 1, 2, 3, 4, 5, and 6 sides. So basically, we just multiply the number of sides, subtract 2, multiply by 180, that's going to be the formula. All right, now we're going to go the opposite direction. It's a little bit more complicated, but not too bad, okay? And what I want you to write over here, I don't know if you guys have access to your book, but page 43 in the book is a list of polygons. Okay. List of types of polygons, but that may not be necessary. Okay, so this one says, the sum of the measures of the interior angles of a convex polygon, we don't know how many sides it is 1,260 degrees. Classify the polygon by the number of sides. So in this case, we don't know how many sides there are. We just know that the formula, n minus 2 times 180, we know that equals, the total degrees is 1,260, okay? All right, so now we got to solve for this, right? So how do we solve for this? Well, we could distribute the 180. I don't really like to distribute, like in this case. I'd probably just, how do we undo multiplying by 180? I would divide by 180 on both sides, okay? So now we get these cancel, and we get n minus 2, and then 1260 divided by 180 is going to be 7. Okay, and a very common thing people do is they stop here and they say, oh, it's 7 sides, it's a heptagon or septagon. Nope, we got to go ahead, we have to make sure we get rid of this minus 2 by doing what? We got to add 2, okay? So it's not just n equals 7, it's n minus 2 equals 7. So now n equals 9. And so it's basically going to be 9 sides. And what kind of polygon has 9 sides? It's called a nonagon, okay? A nonagon. And that's it. So that's basically the opposite direction. Instead of going like, oh, it has this many sides, how many degrees is it? This one's saying, how many degrees, this is how many degrees we have, well, how many sides does it have? All right? Okay, why don't we, yeah, well, if you want to pause the video and jump down to examples or checkpoints 1 and 2, you can do that. Otherwise, we can keep going, and we'll do example 3. But yeah, I'll zoom out here. Why don't you guys go ahead and try the checkpoints, 1 and 2. Otherwise, we'll just keep going, and then we'll go through the checkpoints. All right, example 3 is a little bit different. We're looking for an unknown interior angle measure, okay? So, let's see here. So we have these angle degrees inside of there. Yes, we need to figure out what is x going to be, right? So how many sides do we have here? We always need to know the number of sides for these kind of things. So we got 1, 2, 3, we got 4 sides. So let's go ahead and figure out, like, how many degrees should this add up to? If you know from, like, what we talked about earlier, you should kind of know what it might be, but let's go ahead and solve it just to get more practice. So we have n minus 2 times 180. The number of sides is 4, so we have 4 minus 2 times 180. And 4 minus 2 is going to be, we have 2 times 180. So 360 degrees is what these all should add up to, okay? So they should all add up to 360. So now what are we going to do with this? We got to solve for the missing angle. What do you guys think? Well, yeah, so if all the angles add up to 360, can't we just add up all the angles and solve for x? We can. We can do x plus 71 plus 112 plus 135 equals 360. Why don't you guys go ahead and pause the video and see if you can solve this, and then we'll go through it in a second. All right, we're solving for x. We need to combine like terms. These are all like terms, so these are gonna add up to 318. Okay, and I would encourage you, make sure you combine like terms. Don't just subtract 71 from both sides. That gets kind of messy. Combine all the like terms before you do that. And if we subtract 318 from both sides, we're gonna get x equals 42 degrees. And that's it, okay? All right, sounds good. Again, if you'd like to pause the video and try checkpoints 1, 2, and 3, checkpoint 3 is like example 3. If you want to give them a try, go ahead and do that. All right, checkpoint 1, find the sum of the measures of the interior angles of a convex decagon. How many sides does a decagon have? Like, think decade, it's going to have 10 sides. So we're looking for how many degrees they all add up to. So we're going to do the n minus 2 times 180. We have 10 sides, so 10 minus 2 times 180. 10 minus 2 is 8, so we have 8 times 180. And 8 times 180 is 1,440 degrees. Nice. All right, checkpoint 2 is going the opposite direction. Instead of knowing how many sides we have, we're looking for how many sides we have, okay? So we're going to do the same formula, n minus 2 times 180, but we know that that's equal to 1,620. We know that's what it's equal to. All right, what do we do next? We're going to divide by 180 to get the n minus 2 by itself. So now we have n minus 2 equals, that's going to divide to 9. Then we got to make sure to be careful. We got to add 2 to get n by itself, so we're going to get n equals 11 sides. You know the name of a 11-sided polygon? It's called an undecagon. Think like Uno and like 110, I guess, like like for Uno, and then deca is like 10, so it's like 1 plus 10 basically, right? All right, cool. Example 3 is checkpoint 3 is very similar to what we did in example 3. So let's go ahead and do this. We're actually looking for 2 angles here. This one's a little weird, but what do these arcs right here mean? These arcs mean these are both the same. I'm gonna call those both x. Okay, if you want to pause the video and see if you can figure it out from there, go ahead and give it a try. All right, how many sides do we have here? 1, 2, 3, 4. This is a 5-sided shape, so we got to figure out how many degrees they add up to. So n minus 2 times 180. Number of sides was 5, so we have 5 minus 2 times 180. 3 times 180. That's going to equal 540. All right, so these all add up to what? They all add up to 540. So I'm going to add all these together. So x plus x is going to be 2x plus 68 plus 105 plus 109 equals 540. Why don't you guys, if you want to pause the video, if you got to that point and you're stuck, why don't you give it a try, see if you can solve it. All right, any like terms? Yep, we got to combine the like terms here. So we have 2x. Those are all add up. 68 plus 105 plus 109 is going to be 282 equals 540. Now what? Subtract 282, we get 2x equals, it's going to be 258. Divide by 2, and we get x equals 129. All right, we done? Well, yeah, those are both the same. So measure angle K, they're both equal to 129. So this equals, oops, I goofed up. Measure angle K equals 129 degrees, and measure of angle L equals 129 degrees. They're both equal to x. All right, sounds good. Now, this next part is going to be really not too bad. It's really not too bad. People kind of forget this, okay? So what we need to know is that no matter how many sides a polygon has, if it has 3 sides or 3 million sides, all the exterior angles, which if you look at this here, if you extend a side, right? This is called, angle 1 is an exterior angle, okay? You extend the side and kind of connect it to one of the other sides. Those are exterior angles, but no matter how many sides a polygon has, they all add up to 360 degrees, which is kind of crazy, right? No matter how much, they all add up to 360, okay? So, so let's go ahead and do a problem here. Example 4. Find the value of x in the diagram shown. So we have these exterior angles over here. We're just going to add them up and set them equal to what? We're going to set them equal to 360. So x plus 89 plus 2x plus 85 equals 360. All right, any like terms? Well, we got the x's are like terms. The constants are like terms. So now we have 3x plus 174 equals 360. Subtract 174, we get 3x equals 186. Divide by 3, we're going to get x equals 62. Okay, so that one's not too bad. But basically, you just got to remember, if the angles, interior angles kind of get bigger and bigger, but exterior angles, no matter what, equal 360. Okay? All right, example 5 here. The base of a lamp is the shape of a regular 15-gon, 15 sides. Find the measure of each interior angle and the measure of each exterior angle. It's a little bit different. You'll see what we're talking about here in a little bit here. And what does regular mean? Regular means angles and sides are congruent, right? They're all the same. All right, so that'll come into play in a second here, okay? So a 15-gon, we need to figure out first, let's do A. We need to figure out how many degrees the interior angles add up to. So what formula are we going to use? We're going to do n minus 2 times 180. Okay? All right, and we have 15 sides. We have 15 minus 2. That was bad. I'm going to fix that. 15 minus 2 times 180 is 13 times 180. 13 times 180 is 2340. Now, what are we going to do with that? What do you think? Well, the angles are all the same, right? And if we have 15 sides, we're also going to have 15 angles. What do you guys think we're going to do with the 2340? Well, if all the angles are the same, we can divide the total angles, divide by 15, because they're all going to be the same, and we're going to get 156 degrees, okay? So that's it. Basically, if all the sides, if it's a regular polygon, the angles are the same, so we can just divide the total angles by the number of angles there are, or sides, and that will give us our answer. B is even easier, right? We're looking for the measure of each exterior angle. Well, no matter how many sides or angles a polygon has, what does it equal? It equals 360, right? So we have 360, and we divide by the number of angles, which is 15, and they're all the same. It's going to be a 24-degree angle, okay? So this is interior, and this is exterior. All right, and that's it. Okay, All right, the last example is kind of a checkpoint, kind of a random problem. If you want to pause that, see how you do, go ahead. All right, convex pentagon. Ooh, I think I did this one wrong, actually. Yeah, this is wrong in the notes. Interesting. Okay, so let's go ahead and do this together here. I'm figuring this out in real time. It's a pentagon. Oh, wait, no, I didn't. Okay, we're good. Okay, so I got caught up. This is a good thing to keep in mind here, okay? We're looking for the measure of an exterior angle, right? So in my notes, I had it set equal to 360, but I was like, ooh, but that's a quadrilateral. But no, it's actually okay because a pentagon and a quadrilateral, the exterior angles are always the same, right? So we're going to add these all up. 66 plus 77 plus 82 plus 62 plus x equals 360. So I got caught up on 360. I'm like, oh, we're doing interior angles. That should be something different. But no, we're good. Okay, now I just got to combine like terms. And we get x plus all those numbers are going to add up to 287 equals 360. Subtract 287, we're going to get x equals 73 degrees. And that's it. Okay, so be careful. Interior angles do get bigger, but exterior angles are going to be different. All right? Okay, that should be what I have for you today. Thank you for watching. Have a great day, and we will talk soon.